Hi, I'm Rob, and I'd like to welcome you to this video on Amazon Bedrock. In the previous videos in the playlist, we explored AWS purpose-built AI services like Transcribe, Translate, Poly, Comprehend, and Textract. Now, as we move deeper into the AWS AI ecosystem, Amazon Bedrock is the next logical step. Amazon Bedrock is a fully managed service from AWS that allows developers to build and scale applications using foundation models, which are large pre-trained transformer models that can be used as is or fine-tuned for specific tasks without managing servers or infrastructure. Bedrock provides access to a variety of foundation models from AWS partners such as Anthropic, Cohere, and Stability AI, enabling text generation, summarization, chatbots, and more. Some of the core features of Bedrock are access to multiple foundation models, where developers can choose from different models optimized for text, code, or multimodal tasks. Fully managed infrastructure, so there's no need to provision EC2 instances or manage containers. And the service scales automatically to handle requests. There's a prompt-driven API, which allows developers to interact with models via structured prompts, and it supports text generation, summarization, classification, and structured outputs. Of course, there's integration with the AWS ecosystem, with services like S3, Lambda, and DynamoDB. And finally, there's cost transparency, where you pay per request with token-based pricing, and there's no upfront infrastructure costs. Now, with that overview out of the way, let's jump into the Bedrock console and get started. First, I want to mention that you should sign into your AWS account with an IAM user and not the root user. And the user should have relevant Bedrock permissions such as Amazon Bedrock Full Access or Amazon Bedrock Read Only. But for the demo, I've given my user admin credentials to make things easier. Of course, you should always follow the principle of least privilege, as you're aware. Now, in the Bedrock console, the first thing we need to do is get access to the foundation models we need to use. In the past, you were required to request access to these models. However, as you can see on the model access page, the models are accessible by default. And if we jump into the model catalog, we could see several of the models we have available to us. Just to note though, that if you're going to use models from Anthropic, you'll need to submit a use case form first. I've already done this, but if you haven't yet, you should see a message about it when you access the model catalog page. So I'm going to filter on Anthropic, then select the Claude Haiku model, which is currently 4.5. Here you could check the pricing for the model access, view pricing details, and again select Anthropic. Okay, back in the Bedrock console, we'll scroll up and select Open in Playground. And from here, you could select between chat and single prompt. We'll use chat first, and I'll send a prompt of, please explain Amazon Bedrock in simple terms. Click Run, and we see the response. Now I'll ask, how do I find the powerful AI language models? Run again, and we see the response. Now let's test out a single prompt. The difference between the chat and the single prompt is that you don't have chat history with the single prompt. So I'll select a model of Claude 3.5 Haiku and apply, then add a system prompt telling the model that it's an intelligent assistant which answers questions about AI Agent Insure, which is a fictitious insurance company I made up for my demos. Now I'll upload a PDF file containing information about AI Agent Insure, but you can upload any doc you have and then send the appropriate prompt. Here I'll ask what products the company offers. And we see the results from the document I provided. There are other parameters and guardrails you can set, but I'll let you play around with those on your own if you like. Also, if we jump back into chat mode, we can access the additional settings here as well. Again, I'm going to leave them as is, but I'm going to enter a new prompt of, what is Amazon SageMaker? But before I hit run, I'm going to enable compare mode, which will allow us to see how two models respond to the same prompt. On the left, I'll go with Claude Haiku 4.5, and on the right, Haiku 3.5. Now I'll run, and we see the different responses from the models. Okay, now that we've had a quick overview of Bedrock in the console, Let's jump into Cursor and start working with the Bedrock API. But before we look at the code, let's start the backend FastAPI server and test it out. First, I'll hit the health check. And of course, we see it's healthy. Then I'm going to hit the config endpoint. This route is called by the front end to get the config values for setting default values for sliders in the UI, which we'll see shortly. Now we'll test the chat endpoint, which sends a request to Amazon Bedrock, specifically to the model ID identified above. So I'll copy the ID, then paste it into the request body, add a prompt, and execute. And we see the response from Claude. Now let's jump back into Cursor and launch the Streamlit front end. Then open it in a browser. Here we see the model ID, which was retrieved from the backend config endpoint, with the values for the temperature and max token defaults. We can test the API connection here, which we actually know worked because we have the default values for the sliders. And now we can modify the params and send some prompts to Bedrock. Okay, now let's take a look at the code, starting with the back end. Here on the left is an example of a .env file. You want to make a copy of this and save it as .env. We see the AWS configuration properties. So set your region, your access key, and your secret access key ID. We have the Bedrock model ID and the Bedrock Anthropic version. There are properties for the API configuration and default chat parameters that are returned to the UI to set the default variables for the temperature and max token sliders. In the main Python file, of course, we're importing Bodo3. We load the .env file and instantiate an instance of a FastAPI. Here we're setting the CORS configuration and the CORS middleware, and then instantiating an instance of a Bodo3 Bedrock runtime client, passing it the region from the environment variables. We also set the default model ID and Anthropic version from the environment variables. Then we have classes for a chat message object, a chat request object, and a chat response object, all of which inherit from the Pydantic base model. We have our health check route and the config route, which, jumping down here, we see gets the Bedrock model ID, the default temperature, and the default max tokens from the .env file, and the model limits from the model limits JSON file, where when the model ID is Claude Haiku 45, we pass these values, and if it's a different model, we'll pass the default values. And ultimately, a dictionary with these properties is returned to the front end. The chat and chat stream functions receive chat requests from the UI, call Bedrock, and then return a response. In the case of the chat endpoint, it returns a chat response, which we see here, and the chat stream endpoint returns a response from Bedrock in incremental chunks in real time via server-sent events as they arrive from Bedrock. So jumping into the chat function, of course we set the model ID from the request. For each message in the request messages, we'll append to the formatted messages a dictionary with a role of the role sent in the message, and the content is of type text, and the text is the content in the message, so the prompt. We build a body to send to Bedrock with the Anthropic version, max tokens, temperature, and messages, then call the invoke model API on the Bedrock client, passing the model ID and the body. When the response comes back, we'll read from the body and store the result in the response body. and ultimately return a chat response with the message, again the model ID, and the usage, which contains the input and output tokens. The chat stream function also sets the model ID, and it ultimately returns a streaming response by calling the generate stream function, which formats the message, builds a body, then calls the invoke model with response stream API on the Bedrock client, passing the model ID in the body, then ultimately yields the final complete message from the incremental chunks sent from Bedrock. So really, the main differences between the chat and chat stream functions is the Bedrock API method used. Chat uses invoke model, and chat stream uses invoke model with response stream. Both functions receive a chat request containing a list of chat objects from the UI, and for the response type, chat returns a chat response object, and chat stream returns a streaming response. Now, for the front end, we're not going to take a deep dive in this code because really you could use any UI that you want. You just have to make the appropriate calls to the backend endpoints, passing the required payload. So here we have another example env file, which just has the API base URL to the backend server. And in the Streamlit app, we really need to focus on two functions. The get backend config, which makes a get request to the config endpoint on the backend to get the model ID and the default values for the sliders. And the send message to API function, which sends a user message to the FastAPI backend and returns an assistant response. So the arguments are the user's message and whether to use streaming or not. The endpoint is set, and if we're using streaming, a post is made to the streaming endpoint, which parses the server sent event stream sent back to the API from Bedrock. Else, if we're not using streaming, again, we make a post to the endpoint, wait for the response, get the message from the result, and return it for display on the page. One thing I want to point out before we wrap up this video is that if you jump into the Bedrock model registry and go to the Claude Haiku 4.5 model page, then scroll down to the usage section and click the code example link, you could get example code for the invoke model and invoke model with response stream APIs. So that concludes this video on building an app which integrates with Amazon Bedrock. If you found it interesting, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. In the next video, we'll build a context-aware multimodal chat app with Amazon Bedrock. Thanks for watching.